Hey everybody, let's go back to parabolas. It's time for graphs with Mr. Troy. All right, as I stated, we are going to look back at graphs to make sure we know how to make graphs, because if you can see it, you can solve it. So, we are going to start with vertex form. How do we know it's in vertex form? Well, we've got one set of parentheses squared, no other x's anywhere else. We find the vertex by looking for what is being added or subtracted to x and what is being added or subtracted at the end, more closely related to y. So in this case, our vertex is negative 310. Switch the inside, keep the outside. Now, when we're graphing in vertex form, we're going to use the 1, 3, 5, 7 rule, which says that your first step to the right takes you up or down a multiple of 1, 3, 5, and 7. So in this case, our step of 1 takes us down 3/2 units. Now be careful. This is down 3/2, as in 1.5, not down 3 right 2. Make sure not to make that mistake. Our next step is going to take us over 1 down 9/2 units. Again, not down 9 over 2, but down 9/2, which in this case is 4.5. Well, in all cases, it's 4.5. 1, 2, 3, 4, and a half. Okay, I want you to notice that if I went down 3 over 2, and down 9 over 2, I would get completely different points. They're not correct. Our next step is going to go over 1 down 15/2. So that's 7.5. Or you can count it as 1/2, 2/2, 3/2, 4/2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. At some point, you're going to get far enough on your graph where you can copy over the mirror points to the other side. And there you have your parabola. Now I'll use movie magic to fill it in. Ready, set, go. Hey, look at that. All right. So, important thing, recognize that it's in vertex form. Remember the 1, 3, 5, 7 rule, and remember that your steps are over 1 down 3/2, for example, not down 3 over 2 like you would for slope. All right, our next form is called intercept form, because it is very easy to find the x-intercepts. So to find the x-intercepts, we're going to solve for 0, which you'll remember from factoring is as simple as switching around these two factors. So my two x-intercepts are negative 2, 0 and 3, 0. Now, I'm going to try and find the vertex, but in order to do the vertex, I'm going to look for the axis of symmetry. Let me show what that looks like. Here is that axis of symmetry. It divides the graph straight in half down the middle, and it tells you if you have a point on one side of the vertex, you must have a similar point on the other side of the vertex. It also tells you the x-coordinate of the vertex. So in this case, the x-coordinate is halfway between negative 2 and positive 3, which is 1/2. I'm sure you know how to find an average from an earlier class. So we're going to take that and we're going to plug that 1/2 in to find our y value. We're going to plug in the x coordinate and we're going to find the y coordinate. So I plugged in 1/2 and I got -25/8. So -25/8 is our y coordinate, and -25/8 is -3 1/8. So that's just about here. Now you can use the 1, 3, 5, 7 rule for this as well, but you might find that unwieldy considering we're at, y equals -3 1/8, and we're not on whole number values for x. So we might choose instead to create an xy table for, say, 1 and 2. So let's figure out what those values are. Take a second and plug in 1 and 2 for x. So when I plug those in, I got -3 and -2, and I put those on the graph. The mirror points, though, are not going to be at -1 and -2 because those don't split halfway across the axis of symmetry. So they would actually be at 0 and -1. And let's fill in that graph. I plugged in one more value to the right side, and then also I mirrored it over to the left side because I wanted to be a little bit more sure. So I also plugged in x equals 1, 2, 3, 4 to find one other point on this graph. Our last equation type is standard form. Well, that's almost what that says. Standard form. Close enough. Standard form is when the polynomial is written out in terms of x squared, then x, then the constants. And there are a lot of things that I can tell by looking at standard form. So the first value, the a value, tells me the vertical stretch, which is also known as the opening direction, and the magnitude at which it changes. The b value, or the linear term, tells me something really interesting, and we'll come to that last. The constant term tells me the y-intercept. So I can tell that this graph is going to have its y-intercept at -3, which is right here, and I can tell that it's going to open upwards. Now, what this tells us is that the graph is going to be increasing as it passes through its y-intercept, which means the graph will look more like this than it will like this. A positive value for b tells you that the graph will increase through its y-intercept, where a negative value will tell you that it will decrease through its y-intercept. If you'd like to know why, you can take calculus. How fun! I paused the video to take a sip of my LaCroix and I thought of a funny joke. If you want to know why, just plug in x. Speaking of, we could take that approach. If you just love plugging in x values and y values, well, just go ahead and plug in 1 and 2 and 3 and 4 and so on. So if we plug in 1, we get 2 plus 10 minus 3. That's, 9? I think so. Now, we can't just plot another point over here yet because we haven't identified the axis of symmetry. Do you remember how to plug in the axis of symmetry? X equals opposite of b over 2a. So our axis of symmetry is -10/4, or perhaps -5/2. So remember, that's here. So let's use that information to plot some mirror points. The y-intercept is 2.5 units to the right of the axis of symmetry. So there must be another point 2.5 units to the left. If we take another step over from that, there must be a point at 9, and whatever that value is. Now, we need to plug that into our equation. So let's plug in negative 2.5 to our equation. So y equals 2 times negative 5/2 squared plus 10 times negative 5/2 minus 3. What will the y value be? We get negative 15.5, so all of the way down here. If you were wondering why this first step that we looked at was so big, it was because the graph is further away from its axis of symmetry. As you step further and further away, your steps upwards get much more intense. If you'll pardon the less than stellar drawing, that's what our graph would look like. All right, I hope that was helpful review for you. I will talk to you at a later date. Thanks for enjoying Graphs with Mr. Troy.